All right, hello again and welcome, guys, to G Squared Academy, where you know excellence is epitomized. Now, today, what we want to work out is the unit of K, the um, rate constant here, the unit of K. So, what we have here is a reaction. Well, let me just write a 1 there and put a 1 there. The reaction is first order with respect to A and B. And what we're going to try and do is work out the unit of K. So first of all, we need to work out K. So K would be equal to the rate divided by the concentration of A to the power of 1 times the concentration of B to the power of 1, right? So now our unit of rate is moles per dm cube per second, right? And then our unit of concentration here is moles per dm cube, and our unit of concentration there is moles per dm cube, okay? Or moles per liter, whichever one you prefer. So for us to work out our K now, we just need to cancel units. So we cancel that, and what we end up with is per second over moles per dm cube. So now what we want to do is now translate that to something which makes sense. So per second is actually 1 over second, and we are dividing 1 over second by moles over dm cube, okay, over decimeter cube. So that will work out to be mathematically 1 over s times dm cube over mole. So here we go. This is our unit now. It's going to be equal to dm cube per mole per second. This is supposed to be per second. Let me see if I can clear that off. No, it's okay. So this is supposed to be per second. Let me just cross it out. Per second. There you go. So our unit is dm cube per mole per second based on how we calculate that right there. So now what we're going to look at is, what if the reaction has something which is second order? What if it is a overall third order reaction? We're going to now look at that one. So again, now our K is going to be equal to rate divided by the concentration of A squared, so B to the power of 1. So in this reaction, this is third order overall. This is second order with respect to A, first order with respect to B. So our K is going to be equal to moles per dm cube per second, right, divided by moles per dm cube times moles per dm cube times moles per dm cube. Okay, so what we're going to do is just cancel out one of those. And what we're left now with is per second, which I mentioned already, is going to be 1 over second divided by moles squared, moles per dm cube squared, right? So that's moles over dm cube times moles over dm cube. Now this is going to be moles squared, because moles times moles is moles squared, right? Divided by d, and this is dm cube, so it's dm cube times dm cube, so you're going to add those numbers, so it's going to be dm to the 6th power, okay? And then now what I'm going to do is I'm just going to carry this up here, so to finish working it out right up here, okay? So now what we're going to end up with is 1 over second times dm cube, dm to the 6th divided by moles squared. So that's what we end up with. And there's nothing to cancel. So what we end up with overall now is dm to the 6th per mole squared per second, right? And there you go. That would be the unit for K for an overall third order reaction. And of course, you can work out the unit of K for anything just by following the procedure that you see me using here. Okay, it boils down to simple mathematics. All right, I hope you guys find this helpful, and I hope you're able to use this in your exams and your studies. All the best.